All right, Pascal's triangle. Precal, right? And so what we're going to do is we have a 1 and a 1. Because 1 is 1, right? Okay. And then, what is 1 plus 1?
2.
2. And did we do purple for that one? So that's 2, right? But then there's going to be a 1 and a 1. Okay? And that goes with this guy, right here. And then for the 3, we're going to go with green, right? And what is 2 plus 1? 3. And 2 plus 1? 3. And that's a 1. Right? Okay? And for the 4, right? For the blue, we're going to go, well, what's 3 plus 3? 6. What's 3 plus 1?
4.
And the 1. Does that make sense? And then 3 plus 1?
4.
And the 1. Right? Then let's do the last one. The 5. Okay? The 5, well, what is 6 plus 4?
10.
Okay? And 4 plus 1? And then the 1, right? And again the 10, the 5, and the 1. See the triangle? Okay? And this is the pattern that Pascal found. He's like, oh my goodness, every time I do binomials where I square them, cube them, right? Quartic them, quintic them, right? I'm seeing a pattern. Okay? And the pattern is, think of this. What's anything to the 0 power?
0.
No. Come on.
1.
1. Right? Anything to the 0 power is 1. Alright. Then, we're going to have anything to the first power? Itself, right? So a plus b? Right? So this one would actually be, in pink, we're going to have a plus b, right? Because that's to the 1 power. Okay? Alright. And then in 2, when we square it, what's going to happen is, it's going to go 1 and then 2. So we're going to have an A, and we're going to have a B, right? But then we're going to have a plus 2AB. Okay? And so, what we have out here is going to be a square and a square. And if we think about it, it's going to go 2, 1. And then it's going to go 2, 1. Okay? For the exponents. Because it's a 2. So we're going to go 2. We're going to start with 2 and 2 and go down to 1. Does that kind of make sense? Kind of? Okay. It'll make more as we go.
So
Okay.
is the next one going to be 3?
Yeah, it'll be a to the 3rd power, right?
Yeah.
So this one's going to be, and we're going to step it out a little bit. So we're going to go a to the 3rd. We're going to go b to the 3rd, right? Because it's a third, it's a cubic, right? Then we're going to step it in, and there's going to be a 3 and a 3, right? So it's going to go plus 3ab, and then it's going to go plus 3ab, and then obviously plus b cubed, right? But we need to know what are these exponents, right? And so think, this one's a 3, what's this one?
3.
No, 3, 2, 1. And then none, right? Then what's this one? 3, 2, 1. And then none, right? And that's the pattern. That's the pattern. Now watch this. So for 4, okay, we're going to go a to the 4th, right? Plus plus 4ab plus 6ab plus 4ab plus b, and then to the 4th, right? And then we're going to say, okay, well, this is going to be 4, 3, 2, 1, and none, right? And then 4, 3, 2, and 1, right? And then none, right? Easy, right? Okay? And for the 5th one, what are we going to do? Same thing. A to the 5th plus 5ab plus 10ab plus 10ab plus
1080.
I'm running out of space. Let me redo that. Yes, plus 5, right? So we're going to have a to the 5th plus 5ab plus 10ab plus 10ab plus 5ab and then plus b. There's a 1 here. Okay? So kind of separate these guys, right? And then that b is to the what power? To the 5, right? 5, the same as this. It's a quintic. Quintic, right? So we're going to go 5. You got this, girl? Come on. 5. 4. Good.
3, 2, 1.
And then 5.
4, 3, 2.
Simple, right? Okay? Pascal's triangle.
That's it?
That's it. Okay? So, I'm going to take you a step further.
Okay.
We're going to do these next. Okay? I'm going to pause it here so that you guys have it as